Alrighty then. So, Custom Vision Service is a service that Microsoft offers as part of their Azure program that allows people to easily make their own image recognition classifier, all depending on what they need and what they want. So we are going to show you how easy it is to get started and just an example as to how you can use it. As it is today, it's still in preview. I have no idea how they are going to do it in terms of like costs and stuff like that once it's fully launched. But you can just sign in with an account. In this case, we have a partnership with Microsoft, so I'm using my Cybercom account. But if you have an Outlook account, an Hotmail account, whatever Microsoft account you can use to get started, by the way. So when you sign in, you're good with this screen. To get started, you just make a new project. I'll call it CVS demo. And if you want, you can add a description. And then it has different domains. We haven't really figured out exactly what impact this has, because we've been going with general in the project we're working on. But if you go by the information here, it says pick the option best approximates your scenario. So for this demo purpose, we'll go with general. And this is where the magic starts. So the way it works is that, say in this case, we're going to train the machine to be able to distinguish between a hemlock tree and Japanese cherry. So, and that is done by tagging a group of images with what it is you want it to recognize. So we'll start. Feed the machine with as much data as possible. Now we're just using 10 images of hemlock and 10 of Japanese cherry, but in a more realistic scenario would feed it, say, I don't know, 100 for each category or more. The more data, the better on a general basis. But to get started, you don't need to feed it that much data. It can learn pretty quickly with just a very selected amount of data. So let's train it then. Just push the training button. Now, this information that we have here is how much the machine is able to predict, depending on the information that we're giving it, because the data that you give it is split in images that it trains with and then images that it uses to see how well it can predict its training. So in this case, based on the small amount of data that we had, when it split the images, it got perfect recall. And say our numbers wouldn't be this perfect. Say we would have a precision of 90 and a recall of 89. Then if we want to bump those numbers up, then we just need to feed it more data that's better, say better pictures of the object that we're trying to recognize them.
Say again how is the precision and the recall calculated? I got distracted.
So how it works generally in machine learning is that the data that you feed the machine is split up into say you feed it with 100 images, then it will take I don't know, say 60% of those it'll take for training purposes, and then it'll use the remaining 40 to test that model.
So the precision and the recall then, how are they calculated?
It's using what's it called? K something. I can't remember exactly. Oh, wait, this. It uses cross-validation for. Where's the? Here. The precision of the recoil indicates by processing using k-fold cross-validation. I haven't actually read that much on what it does and what it means, sadly, so I can't give you information about that. But now our model is trained, and we can test it quickly to see how good it is. So let's give it a hemlock image. It's analyzing, and the machine is 99.9% sure that it is hemlock. And say Japanese cherry. It gives us a similar result. And if we feed it something else to try and recognize, in this case our cardboard glasses, it is not so sure that it is any of the two. So
like hemlock.
yeah, that's the question. Like 0.2 of hemlock. I'm guessing that it has something to do with colors. It is very sensitive when it comes to light. If it's very light, if the picture is very bright, colors and all that. So, and again, it would depend on. Say you have an application where you want to recognize different kind of furniture in a room, for example. And then we feed it with all sorts of pictures from of different furniture, and then we can go into any room and see, okay, but what kind of furniture is that? And say we develop an application for that, and then we can just take a picture of it, send it to the service, and it will feed us back data. Oh, I recognize this as a whatever model for furniture and stuff like that. Or say you wanted to recognize different kind of animals as well. So then let's say you wanted to recognize exotic animals, and then you can use it as an educational purpose that kids can take pictures of different kind of animals and they'll get the information about it's this kind of animal or stuff like that. So
Actually, you are using this for your project.
yes,
right?
we're using this
You
for
can
our
say-
project.
You can say what it's about, perhaps.
So what we're doing is that we are trying to get the machine to notice a difference between if these glasses have been assembled correctly, because one of the issues that Johan has told us that they have when people construct these glasses is that this particular part here is not always put in place, so sometimes it will be misassembled and it will look like this instead. And it will often, like the part in the middle will often be obscuring the vision for either of the eyes. So we are trying to make sure to train it and to pick up that it's been assembled correctly, so that people can get live feedback. Okay, I've assembled it correctly, and it won't interfere with my use of the cardboard glasses.
So it's after production quality assessment, and it's not only that. I mean, there are like the tab that separates is sometimes off place. The QR code that is printed on the side is blurred sometimes. Sometimes people bend it wrong way. So all of those kind of failures are common, and that's what you are searching after.
So we are trying to feed it as much data as we can to see if it is a good fit for what Johan wants for the project and for the feature that he wants to implement in the Smarta Fabriker application.
So do I understand correct that you will use this functionality later on in another application?
That is correct.
And can you specify sort of parameters for recognition, sort of like outstanding points within the image where the algorithm probably most likely can recognize it, like here the eyes, not the eyes, but the two holes in the middle? Can you influence the parameter, how it's, or can you influence the neural network in some form?
No, as it is right now, we can't. The only the way it works is that you feed it images that you tag, and it tries to learn that, okay, so what is it feeding me? What is the user classifying it as, and tries to memorize what this is based on how we I believe it maps things on a pixel basis, but I'm not entirely sure about that. So it will compare images based on pixels. How
So
it constructs.
you cannot customize at all.
Not as it is right now. I have no idea if Microsoft are going to expand this this service to allow that or not.
But
It's currently in beta.
have you tried to cheat? Like, if you feed it pictures with that line on that spot only, and you give those pictures in the correct folder or whatever, will it train itself to recognize the line?
That is the issue we're currently facing, because like we've fed it with data with different kinds of backgrounds, colors and stuff like that. In both cases where the line in the middle is missing and when it's present. And as it is right now, it's very random in how it returns the result. So we're not sure if it can pick up minor details or if it does, because it's so inconsistent. We are currently doing a statistical analysis where I'm basically trying to feed it over 600 images and just pull statistics to see if it's just, you know, random or it's actually doing what it's supposed to do. So yeah.
I have a question. Do you know if there is some kind of like API you can use to link that system?
Yeah, exactly. So I was going to get to that. So now that we've if we go back to the other to the demo project. So say I'm satisfied with this now and I want to use this, and say that I want to implement it in my web application, then I can call this train model using a prediction key. So I just write the functionality in the website, and then I use this key to allow the application that I'm using to call on this service and use it. And as a .NET developer, I might also add there are packages that you can use while developing, rather than doing this, like, you know, coding and then doing all the training and stuff like that through the web browser. You can do everything in code if you're a .NET developer. So there are packages for
using that on a website, for instance, to allow users to drop pictures into the place and get.
Yeah, exactly. So say we develop an animal recognition application, web application. Then yeah, people can just feed it images and the service will
Does
give.
it work in real? Like, if we have a video instead of a picture, would that work or?
No, it doesn't take video at the moment. I believe I've read somewhere that they have thought about allowing some form of video recognition, but I have no more information in regards to that, if they're going to go through with it or not.
Google has it.
So yeah.